All right, hello again, or hello for the first time to those who have joined us in the last few minutes. I'm Seth Grimes. I am the program organizer today with the New York and Washington, D.C. natural language processing meetups. I'm really glad to have a whole bunch of partners, but before getting into that, we're at 55 attendees so far. We are in webinar mode, which means you're not visible to each other, but I'd be happy to give anyone who's attending now 30 seconds or a minute to talk about your NLP related work and any needs or offers you might have. That could be hiring or for a job, funding, or an investment offer. It could be a technology or product question. If you want to speak in just a moment, please use the Zoom raise hand feature. We are going to have two speakers today, whom we'll get to after that. I want to thank the partner meetups for this online program. They are especially today Zurich Natural Language Processing, also Stockholm NLP, Philadelphia NLP, and Ann Arbor, Detroit, Michigan, Hungarian NLP, and DC NLP. For those who are members of my meetups in Washington, DC, and New York, I am hoping to go back online. I'm hoping to go back in person for programs as soon as September. I'm working on finding out about venues. So if you are in or can be in either of those cities, Washington, DC or New York, and would like to give a meetup talk, please message me. I'm going to provide my contact information here. Oops. There we go. My contact information. It's possible we'll do some more online programs, however. So if you'd like to give a talk, and I'd be happy to get a proposal from you for that. Now, we do have made up videos for the online program starting in March of 2020, posted at the NLP XING YouTube channel. So you can go there, and I also listed the Twitter handle for that. And then finally, I see I have a question. The in-person programs, yes, I would hope to live stream the in-person programs, and I would do that on YouTube or on Zoom like we're doing right now. We would try to allow remote involvement in the sense in the Q&A, but I would not have remote speakers. Part of the fun of the reason for having a meetup program in person is to be able to interact with the speaker. And I think we really need to have speakers who are going to appear in person in each of those cities. So again, if you'd like to give a live presentation in Washington, DC or New York, I'd love to hear from you. Again, we'll consider doing some additional online programs as well. Finally, I want to thank the two sponsors of the New York and Washington, D.C. natural language processing meetups, which are John Snow Labs, the publisher of the Spark NLP open source package with some additional components that are not open source for healthcare and perhaps other areas, and then Kensho, another tool provider. Let me see. You're welcome to introduce yourself in the chat. Once again, if you'd like to speak for a few minutes, then you should use the Zoom raise hand. No, I'm sorry. If you'd like to speak for up to 1 minute, you should use the Zoom raise hand feature, and then I will promote you to panelist. We're going to start with one person whom I agreed to give more than 1 minute, and that is Walid, who is going to spend just a couple of minutes talking about a text annotation tool that he has developed. I have promoted you, Walid, to be a panelist, and you can start your video. Perfect. And I'm going to stop my own screen share so that you should be able to share your
okay.
And you can go ahead.
Perfect. Thanks, Tess. Thanks a lot. Share screen. So let me know when you see the screen, if that works or not. Do you guys see the screen?
Yeah, it looks good. Go ahead.
Perfect. So I present myself. I'm Walid. I'm the founder of UBAI. We are actually a new text annotation tool. We launched in March 2021. So today I just want to present a little bit about our product for the meetup community. So if anyone is interested, just check us out or send me an email. So basically what we offer is an easy to use text annotation tool that will allow you to do NER named entity recognition annotation, as well as relation annotation and classification of the text, all in the same interface. You can easily switch between tabs and then do the annotations. We also have a team management function. This will allow you to invite your team members and then do the annotation together, and then you can measure the agreement of the annotation using our inter-annotator agreement function. We also have an option to do auto annotations. So this is in case you don't want to do manual labeling for a very long time. So you could train a built-in machine learning to do the annotation for you after you annotate a few hundreds of documents or so. So this is very handy to minimize hand annotation. And the last function we added was the OCR annotation. So this is in case you want to annotate invoices, receipts. As you know, the layout is very important, not just the semantics of the text. So this will allow you to basically annotate directly on PDFs or JPEG or PNG or scanned images. So in this case, I have this driver license, this very famous person here. And then we have research articles, for example, annotation and invoice. Those are the main functions. So if you guys have any questions, please don't hesitate to send me an email at admin@ubi.tools or visit this website here. You'll get more information. Thank you so much.
Great. Thanks, Walid. Just
Thank you.
one final offer that if there's anyone else who would like to speak for a minute, then you should use raise hand. I do see I have another taker, Jose. I'm going to enable you right now. Jose, please introduce yourself, your name, your organization, and anything else you want to say. Go ahead for a minute.
Hello, everybody. I'm so excited to be in this meetup. Thank you, Seth. So my name is Jose Berengueres. I'm a professor in Dubai, and I'm talking today from Stockholm. I'm into data visualization. I'm also a Kaggle master, and I'm super excited to learn more about NLP because it's taking over the world, and it's super exciting. So I thought we could share our LinkedIn's and bios in the chat. So I just share mine, and I hope everybody shares a bit so we can connect more to each other. I'm also a bit of an angel investor. So if somebody has some cool AI idea, feel free to connect with me. Awesome. And now back to Seth. I'm looking forward to this seminar. Yeah.
Great. Well, thanks, Jose. So I have put Jana Lipenkova on screen. Good, I see you, Jana, and you can unmute yourself and start sharing your presentation. I'm really glad to have Jana back to speak to us today about work that she is doing at Anacode in Berlin. And she has spoken to the meetup once or twice before, and I've had her speak at one or two in-person conferences. So it's good to see you again, and please get started. Now, it's up to Jana whether she wants to take questions during the course of her presentation, but please use the Q&A feature for your questions. And then if you, again, after her presentation, if you want to ask questions and be voice enabled, then use the raise hand feature. Jana, please go ahead.
Yeah, thank you, Seth, for the introduction. So my talk is quite short, and I think it's better if we just do the questions at the end of the talk. Okay, so hi, everybody. My name is Jana Lipenkova, and I'm really excited to speak today about the topic of disentangling the AI landscape using automated web monitoring. So the product or the tool that I will present is basically a tool that we have developed at my company, Anacode. At Anacode, we do strategic market intelligence using big data and AI. And what we have seen in the recent years is basically that it's getting more and more difficult to kind of embrace and grasp the whole AI landscape. And we have seen this both for people who are kind of new to AI. So for instance, many of our clients, they come from completely different areas, and then they have difficulties understanding what the field is about, what it embraces, especially also attention on to get maximal benefits for their business. And we have also seen this for people who are deeper into AI. So I'm talking now, for instance, about my own team and also myself, although I have a PhD in NLP, but still it's more and more difficult to find all this time also to stay up to date with everything that's happening in the field. And this is why we have used our technology for web data collection and also for natural language processing, basically to build the AI Trends and News Monitor, which is there to you and to help us solve all these issues. My talk today is a quick spotlight. So present the concept and the vision behind the AI Trends and News Monitor. Then I will show a quick demo of the tool. I will explain the backend, and finally we can discuss your questions and of course also any additional ideas, because the tool is currently in this beta phase. I'll tell you how you can get test access if you're interested in trying it out. And of course, we welcome all kinds of feedback, both on the backend, the data, and then also the UX and the business model ultimately of the tool. So a new way of accessing AI knowledge. So what do we see? What's currently happening in AI, as actually also in many other emerging technologies? We have first a growing complexity and globalization. So we have things that are happening at multiple levels. For instance, they are happening in academia, but then also R&D departments, companies. They can also happen in all these exciting governance topics that have been arising in the past years. And of course, more applications are based on AI. So there are all these different levels which also interact between themselves in many different and very fascinating ways. And the field is getting more and more global. So we have, let's say, the two maybe giants are the US on the one hand. On the other hand, they have completely different approaches to AI. And then, of course, we also have Europe, we also have all the other very exciting things are going on. And you really, so if you want to understand the field, then you really kind of need to see it very globally. Then we have shorter innovation cycles, so new algorithms and new applications more quickly. And finally, on the other hand, kind of this feeling of being overwhelmed by all the AI content that's out there. So on the one hand, there is a lot of it, and on the other hand, also created for the purposes of marketing. And then it's not always objective, it can be biased, and it can also be overly simplistic. And this is why we created the AI Trends and News Monitor. So basically, it's a tool that collects large quantities of data from the web and then structures them using natural language processing and the taxonomy, which is like really focused on the AI domain. And thus it helps you to disentangle and to embrace all the different topics and the different layers that you find in the AI landscape. We have built it internally, so completely internally at Anacode, which means that it combines the big data that we have, so a very large databases, and then it also combines domain expertise that we have inside of the technical team. And the monitor, well, it's a monitor, so basically the insights that it offers, they come not really real time, but they're always updated basically to the preceding day. So what's in it for you? First thing, all of us, I would say every professional, so we don't have like exact numbers, but there are definitely studies that confirm this. All of us spend a lot of time browsing the web and doing web research for what we do professionally. And this is something that can definitely be reduced when you have automated tools for monitoring and focusing the specific domain that you're in. Then as a business, once you combine this structured information that you get with your unique business model, a unique information advantage and build it out over time. And finally, you can of course also get your own business, your projects, your business model, and so on. So now I will first show you the front end in 1 minute or two. Okay, so basically it is built on multiple levels. So we start with an AI taxonomy, which contains different sections. So you can see we have a section for use cases, we have a section for AI domains, a section for algorithms, for governance topics, and so on. And each of these sections, it's further decomposed into additional topics. So it's just a hierarchical taxonomy, basically. Let's click on AI domains. And now let's say that we are interested in, surprise, surprise, we are interested in NLP. And then basically it will go down and drill further down into the more fine-grained topics. So this is like the first level of the tool, basically a taxonomy to yourself and to understand what the relevant topics are. Now, additionally here, of course, for many of these topics, by the way, here, the size of the topics always signals their relative prominence in the data. So for instance, here, conversational AI would have, you can frequency, whereas if we go on a more specific topic, then it has a much lower frequency in the data. Additionally, when you want to drill down on a topic, then we just click on it and we will come basically to the topic where we have more fine-grained information. So we have a quick summary here with some related topics. Then we have the news feed for this topic. So at the moment it's filtered by, it's sorted by relevance. You can also sort it by date. You also have additional search and filter options if you're looking for more specific information, because otherwise you might also get lost in all these articles actually. Then here we have a time series for that shows how its prominence has developed over the past month or years in this case. And additionally here we have additional context information, so the industries for which this topic is mostly prominent and the companies which are very active in this topic, and then also some keywords which are frequently associated with it. So this is our second level of detail, basically the topic profile. And additionally, we have here one professor. So one thing that we see very commonly with clients is that, of course, they look at a specific data point and then they want to know, yeah, but does it come about? So what's behind it? So they want to drill. And this is something that we also allowed to do. So all of these charts are interactive. You can drill down on any data point, and then you will see the specific news items and articles basically that are related to this specific data point. Good. That was it for the quick demo. So briefly for the and how to benefit from the tool and how to actually use it. So you can use it first to gain market and competitive intelligence, because it also has the associated information about that are present in specific topics. Then you can, of course, use it if you want to stay up to date with academic and technical developments in artificial intelligence. One thing that I use it personally very often for producing on AI. So for instance, for specific talks, for blog posts, even posts, and so on. And of course, also as an inspiration for your own development. It contains a lot of scientific articles, it contains a lot of tech blogs, and then can really help you discover specific connections that would be hard to see with their eyes if you just read through the data as a human. Good. Now I will explain briefly the backend and the technology. So really quick, basically our data pipeline is more or less a classical pipeline, which starts with raw data, and then it has multiple steps of structuring, and then it gets to the insights. So as said, in terms of the data, we mostly work with web data that we crawl in daily time intervals and that are mostly unstructured. I will go a bit deeper into the data on the next slide. Then we have the component of natural language processing. So since the incoming data is unstructured, our step is to, well, after the pre-processing, is to bring it into a structured form. So here we use embeddings as our basis for the pre-processing. So we use both word embeddings and sentence embeddings. And then after this pre-processing, we have a toolbox of algorithms, so including sentiment analysis, topic classification, relation structure the data, and allow basically to extract structured insights from the data. That we use here, they are developed for a multilingual. We include English and Chinese data, and of course we also then plan to include, let's say we are seated in Germany, so German is language that we include, but then also more languages into the database. And then the third step is in expertise, because what we have learned in most of our natural language processing projects is that it's well, it's just not always enough to provide the output of an LP, then maybe to aggregate it in specific ways and then just to put it to the client or to the user. So we need to include this additional level of domain expertise. Here we have the and also the maintenance of our AI taxonomy, because as all of us know, AI is changing very fast and we have new algorithms, not to speak of new companies that come in all the time. And all of this somehow also needs to be reflected in our taxonomy. So this is why we also use an algorithm for detection of new topics and new trends in the data. We also have our own named entity recognition for company discovery in the technological space. And finally, we also have industry verticals where we basically can filter and analyze the data by industries, because of course this is also very important for users. So if you're in healthcare, for instance, then you have completely different information requirements than someone who is in automotive or in the finance industry. And in the output, so what we provide, you have seen it in the front end, are instant AI insights into the whole AI space. Before I go into some details here, maybe some words about the tech stack. It's Apple, so the whole pipeline is used in Python and is built in Python. And we also use Python for the data visualization, the front end. So we use Dash Plotly, which some of you might know. And we have seen that for the data visualization needs that we have, it actually really works very well. And it also allows to kind of integrate the backend and the front end very seamlessly without requiring additional JavaScript overhead or additional basically data visualization overhead. So here, I would now like to briefly focus on 2 points, which are both very central to our application, but then they're also central to our users, which are the databases on the one hand, and then the taxonomy construction. So first, for the databases, what we have seen when we start is that different people, of course, have different opinions about what AI is. So if you're a developer, then she or he has a completely different idea of what AI is than if you go to a consumer. And this is why for us it was very important to integrate multiple perspectives into the tool just to get a max view of the landscape. We do it by using different data sources, which also focus different target groups or different stakeholders. So we include mainly general press, which reflects the perspective that consumers have, the business and the financial press, which is more for the, well, investor perspective, or in general the perspective of executives. We include technology blogs, which then are more focused on the developers. And finally, we also, of course, include a whole bunch of scientific publications, so findings, journal publications, and so on, because of course this is probably the basis of the things that are happening in AI, and they really reflect of academia and of researchers. So that was one thing, and then the second item, as said, and the maintenance of the taxonomy. So taxonomies are normally very tedious to maintain, and this is why here we have developed and we are optimizing an automated algorithm which allows us new topics from the data and then also to integrate them in place in our taxonomy, so in our hierarchical classification. Well, we started with a classification of the different AI areas, which you have seen in this big wheel in the front end, and which you can also see on this chart. So there we have concepts, data strategies, and so on. And then we use a proprietary natural language processing algorithm, which is mainly based on lexical relations, such as hyperonymy, so which is basically a hierarchical, as we would have it in a pattern like neural networks such as CNNs, RNNs, and so on. And from this simple surface pattern, we can then learn that convolutional neural networks are a kind of neural networks. Well, that's an example, but you get the idea. So on the one hand, we have syntactic and lexical data, which allow us to detect this kind of relations. And on the other hand, we also then use a more latent algorithm, which allows you to discover relations between the items which don't necessarily occur context of a phrase or of a sentence. So this algorithm is a bit complicated, and then I just tried to explain. And if you are interested, then I have a paper actually which is forthcoming in the ACL conference, so in the demo track, which is really focused on this specific algorithm for automatic taxonomy construction. So you can check it once the proceedings are published, or just get in touch, and then I'll be happy to provide you additional information about the algorithm and also additional materials. Good. Now, before we jump into the Q&A, as said, we are now welcoming for the beta version. So if you're interested to try out the tool, then you can just send an email to info@anacode.de with the subject line AI_insights_DC, and we will get back to you quickly with your personal access details. And as said, we are really happy to hear any feedback on the tool. And this is something that we really believe in, that technology so fast that we just need new tools and new methods and also a new mindset about how to access technology knowledge and AI knowledge. Thanks for listening, and let's jump into the discussion.
Thank you, Shauna. You have one question in the Q&A. Let me read it for you. So for these different data sources that you're looking at, are you purchasing these directly from the vendors, or is all of this being scraped?
At the moment, we are crawling them 1%. Yeah. So, I mean, purchasing would probably make the case. It would include social media, but that's not like social media like Twitter and so on. But that's not something that we do at the moment because we really want to focus on the more professional and the more detailed sources, basically. So professional press and then also the scientific publications.
You have a couple more questions, but before that, attendees, if you'd like to be voice enabled for your question, please use the raise hand feature. You have a question, Jana, from Walid Jimono Muna. You retrieved results based only on English resources.
So English resources and the Chinese resources at the moment. So at Anacode, the background is basically that we first started from market intelligence for China, and this is why our Chinese NLP component is actually the strongest one. And it comes in handy when looking at AI, because of course, as I said, China is just one of the superpowers and really development in the space.
And you have a question from Martin Berger. The tool looks great. I was wondering if you could elaborate on the trend mining part. What makes a specific topic a trend, or is it just a topic count? Do you recount your scraped, separate question, do you recount your scraped corpus every day?
Mm-hmm. Okay, so for the trend mining, it's not just the topic count, but it's really the development of the topic. So currently we use basically the last 6 months to calculate, and then it's really how steady and also how fast or well, how slow actually the prominence or the frequency of the topic was increasing. But based on frequency, although we are thinking about including like other metrics, including sentiment analysis also into the trend calculation. And for the second question, well, yes, the corpus, actually the crawling runs continuously. So it runs every 15 minutes. But then we update the analysis part only daily because that's what the users are content with at the moment.
And maybe one final question you have from Miriam Kazmi. Does the search engine taxonomy concern only data science related topics, or does it address other fields? Are search results all research papers?
And our search results. Okay, so at the moment it's focused on AI, but the framework is quite scalable. So we really want also to integrate other technology domains, and the next ones that we are targeting are cybersecurity and fintech, but then also, you know, the blockchain and all these things can also be covered, since, as you have seen, the taxonomy can be maintained automatically to a big part. This process is then also very easy actually to scale. But at the moment, we are really into developing a very viable usability framework also for the tool. And that is then we can also scale to other emerging technologies.
I don't want to cut you off. You do have a few more questions. Jose asks, any advantage compared to a human expert? Can you elaborate?
Well, no, sorry for that. Well, first, the thing is, of course, that, well, that's a question of belief. Yeah, if you believe that automation has some advantages, then it has, and if not, then you know it's very difficult to get them. But the thing that's very objective here is that, of course, it helps you to save time tremendously. Yeah, because we have a huge data corpus in the backend, and a human expert would never be able to comb and to read through all this data. And the other thing is that when you're using AI, you're just really able to make connections and to discover new concepts that would be very difficult to spot for a human expert because they're so latent.
So speaking of human experts, though, you do have a question. Did you have to construct labeled data sets to train the model? And then there's also a question from Walid about supervised relation extraction. So data sets for training the model?
data sets for training the model. Well, let's say that our the biggest part of the manual effort that we had was like really at the beginning when we had to construct this a manual framework for the taxonomy and determine how it's structured and so on. And after that, we basically used this small set of concepts, relations between concepts as a seed set. We use them to annotate data and then also to expand the taxonomy automatically. But we didn't do like any raw text annotation.
And supervised relation extraction, or does it extract only open relations? I'm not sure what's, anyway, yeah. Supervised relation extraction.
Supervised relation extraction. Well, the way that it works is that so basically the relation extraction is mostly linguistically based. So we work a lot with parsed data, and then we have this specific set of relations that we need to extract, like cooperations, specific developments, and so on. And then they're just recognized based on the verbs, mostly verbs or nominalizations of the verbs. So to be frank, I don't know exactly what open relations means here. Maybe it means like an unlabeled relation.
That's unclear to me either.
Yeah.
Why don't we move on? Jose asked for an example. I assume that's an example of comparing to human experts, since that's what he asked about earlier.
To human experts. Okay, so you mean some knowledge that the tool could detect compared to human experts. So one thing that we actually used it for with our clients is for discovering technologies that have scalability effects in other industries. So for instance, client who had a, well, I will not go into the detail, so because it's confidential, but it was a technology for the automotive space. And then using the tool, they actually discovered new use cases for this technology in the healthcare space. Yeah, and this would be really difficult for a human expert because, well, you cannot be an well, you can, but you would have to be an expert in AI, in automotive, and in healthcare in this case. Yeah, and that's something basically that can be done automatically if you rely on it.
Let's take one final question from Q&A, and then I have Sai Krishna wants to be voice enabled. Catherine Olson asks, you mentioned Chinese resources. Are those Chinese language resources or English language resources from China?
Well, when I say China resources, then it's mainly Chinese language resources. Yes, we also have English language resources, but then the content is always a bit more filtered than if you take the original content in Chinese.
And final question from Sai Krishna.
Hey, thanks a lot for the session. Quick question here. So when you say relational extraction, someone else also asked this. I think maybe I can voice my question much more clearly. So is it like we take a sentence and then you have your subject, object, verb, and the different relationships between those subjects and objects via verbs or other relationship possibilities? You tag those relationships along with the words, and then you build a supervised model saying, hey, if you see this word occurring in this sequence, then somehow learn that this is a relationship between these two. Or do you say, or you build another model saying that this is an object, this is a subject, and this is a relationship? You get
okay.
what I'm
yeah. I think so. Yes, it's the first variant. So then in this sense, it would be supervised relation extraction. So we have of relations basically that we want to extract from the data.
Okay, thanks.
All right, thanks, Shana. We're going to stop there. You got a lot of good questions, which is a mark of a good talk.
Yeah, thanks a lot. Yeah.
So, we do have a second speaker today, and that is Jason Lee, who is going to be speaking on topic model aggregation. So we're going to turn it over to Jason now. Once again, thank you, Jana. And Jason, I see you on the video, and you can start your share, and we'll test your audio.
Okay.
Sound good?
Okay, can you see the screen?
Yes, you want to just go into presentation mode.
Sure. All right, 1 second. Okay, yeah, how's that?
That's good.
All right, thank you. All right, yeah, hi everyone. Yeah, thanks for listening in. I'm going to be talking about aggregating topic models at scale. And just to give a quick agenda of the talk, I'll just give an introduction and some context on the project, and then just describe the project we've been working on, aggregating topic models, and how we've been scaling that with PySpark, and then some next steps I've been thinking about for the project. To introduce myself, I'm a staff software engineer at Flatiron Health, working on integrating radiology scans into the Flatiron ecosystem. This project I'm describing is independent of any work I've done at Flatiron. It's sort of an independent project I've been working on for the past 3 years, and in conjunction with a partner at the University of Cincinnati Digital Library, my brother who's a professor there. And we originally started looking at Renaissance text, and more recently looked at the Cord19 data set, but then have been expanding for other things as well. So I'm also coming at this from perhaps more an engineering pipeline perspective. So some of the UX portions and maybe the data science portions may not be as strong, but yeah, I'll take it for what it is. And I think hopefully there's something interesting for you all here. All right, so going into the discussing aggregating topic models. This topic modeling primer, and maybe don't have to go over this in that much detail for this audience, but basically for the topic models are a powerful tool in order to be able to extract in an automated bottom-up way themes and topics from a document corpus. However, there are drawbacks and shortcomings, and which I sort of illustrate sort of on the bottom, sort of sensitive to initial conditions, leading to topics sometimes not being reproducible. Just quote this, saying, yeah, this is something that is mentioned elsewhere in the literature. So problematic when seeking to capture a definitive topic modeling solution for a given corpus, and there's a fundamental instability in these algorithms. And it's essentially different runs of the same algorithm on the same data can produce different outcomes. And so some other drawbacks is that the number of topics has to be selected as a parameter. And there are methods in order to be able to sort of automate that, but it is still a input variable, and can be noisy. There can be noisy, difficult to interpret topics, and may require a manual step for human annotation. So this is some of the motivation for the work that we were doing to aggregate topic models, so that for a given set of input documents or corpus, one can aggregate the recurring topics across different runs. So what this is, for example, for the experiments that we've done, we've run 50 plus models using different topic counts, 50, 100, 200, 400. And what this will allow is for the consistent topics to bubble to the top. And I think this is a way, more natural way to get the number of clusters topics, and also allows these clusters to smooth out the terms, even for topics which often do make sense. There may be sort of extraneous or stray terms that sort of filter in or bubble in, but yeah, being able to aggregate them across multiple runs helps average those out. These clusters are formed by aggregating topics using pairwise distance below a certain threshold. So we use Jensen-Shannon as the metric. And then there are also some network-based heuristics in order to refine the clusters as a post-processing step. And we do a grid search to determine the best combination of topic sizes, threshold distance, using coherence as a measure for which of the models were successful in that case, in that respect. And the topic sizes, combinations of 50 and 100, 100 and 200, 200, 400 are all the topic sizes. And then there's a confidence based on the ubiquity what I've called ubiquity across the models. So you'll have 50+ models, and certain cases, rare cases, you'll have them a topic be consistent across 90% of the models, but more likely it'll be maybe even 50% or higher is pretty good. Or even if you're going over 25%, 50+ models, that's still about 10 across 10 models, and that seems to indicate that there would be some signal there. And as I mentioned, I've been working in conjunction with the my brother at the University of Cincinnati Digital Library. He recently published a paper looking at the Core 19 data set, which is a set of research papers around COVID-19, but also other epidemic diseases such as, in the paper, we created models for COVID, SARS, MERS, HIV, Zika, and checked against a set of annotated, human annotated labels, whether the topics corresponded to those labels. And there was a 71% correspondence, which suggests the validity of the approach, and can think of this as potentially a way to sort of streamline or expedite human annotation using these high confidence clusters output by the model. And there is relevant literature along these lines. So as I was preparing for this presentation, I did a little more research, and there's a paper, Aggregating Topic Models for Increasing Social Media Topic Coherence. So they suggest a similar approach using aggregating topic models to help increase the coherence score. So I think it's there is some theoretical underpinning there, but and I think you can consider this an implementation of that. There are some specific benefits where we have the confidence score across multiple models and some heuristics to continue to chunk the clusters afterwards. But yeah, I think there's there have been other opinions of use this approach. Let's see. And to give you sort of an outline of what the architecture for this is on the left-hand side here, you can see the backend pipeline, and on the right-hand side, the various outputs for this for the project. And basically, I'll go over some of this in more detail a little later on, but you can think of the inputs on the top left-hand side, a search against Elastic in Elasticsearch, where we have all the PubMed documents indexed, and that would be the input corpus for the pipeline, which we pass into Spark LDA in this case, and a pipeline built around EMR and Spark in order to be able to scale that. And the output would be some of the visualizations on the right, PyLDA Viz to view the individual models, plus a text and graph-based output shown on the right. And I'll just go into them a little bit more further later on. To dive into the topics a little bit, here doing a comparison of the underlying topics for a PubMed search for machine learning or artificial intelligence. So these that returned about 30,000 documents with one of those keywords, and these are the topics that came out of that, individual topics on the left-hand side, and the aggregated clusters on the right-hand side. And I just highlight one of the topics, one of the clusters, say the eye disease and glaucoma, and you see that the first two topics are relatively consistent. They're across different models. There may be a little bit of noise. In the first one, you see glaucoma eye lymphoma. I don't have the clinical expertise, but I feel like it's maybe not. Yeah, that might be a little bit of noise. And on the right hand side, you'll see that if you see on the right hand side on the bottom, the eye glaucoma lost visual field. Yeah, that's the top terms for the clustered output, and say something like lymphoma is averaged out from the aggregated result. But if you look at the visualization on the bottom right and sort of the zoomed in version, you can see the various nodes. Every node is a topic across one of the 50 runs. And these are the particular topics that clustered around the eye glaucoma theme. You can see there's another one very close by for eye disease and diabetic retinopathy. And they are proximate but distinct. So they have a distinct set of documents and terms associated with them. And just to highlight on the left-hand side, there is for an example of where there would be a noise topic that would appear. This cow glaucoma topic was one that appeared, and I looked through the various documents. I couldn't see where the co-occurrence may have happened, but that there was something. It was not a topic that recurred across multiple models. So this is the type of model that would get filtered, kind of topic that would get filtered out by this approach. Yeah, and as I mentioned, the visualizations here, actually refer to this as MOL. MOM. We've been referring to this just as the model of models, and that's what that reference indicates. The visualizations, see, we generate sort of a cache view of the Pi LDA viz just to be able to drill into the various individual models, then a text-based view to get a summary, and some charts based on just to get some analysis on sort of the trend over time for a specific cluster, as well as in the case of PubMed, the publication, we also indexed PTO documents, and for that, I think it could be potentially insightful to see what companies have patents that around a certain theme or cluster. And finally, on the bottom is a graph-based view. That's we use cytoscape.js for that, and I'll just do a quick demo on that. So, and this is a tool that mainly built to better understand how intuitive these models were. So it's has been more a tool to for getting a view into the data, but so it's we definitely certainly could be improved, but you can see that here you can see the eye disease cluster here. If you click on that, see the individual topics on the right-hand side and the documents related to that cluster on the left-hand side here. So see, there's the information for the particular documents that show up here. So and the main thing that we want to that they've been looking at is the actual documents. So we wanted to make sure that the documents were had a sort of a primary focus in the navigation. you can, as I mentioned, there's sort of the concept of ubiquity. So here by default, it'll show clusters for which topics have appeared more than 25% of the time. But then you can also look at topics which are less frequent, so greater than 10% and less than 25%, which might be noisier, but maybe if there may be something of interest in this set, and that for whatever reason didn't bubble up further. If for whatever reason, say convolutional neural networks did not appear in more than 25%, it may be that yeah, so it may be that there were other topics for which CNNs were folded into other clusters, but there is this one specifically for CNNs here that did not that appeared in 10 to 25% of the clusters of the models. Yeah, so that's for the demo. Actually, maybe I can pause right now for questions to this point, and then I can talk about the optimizations afterwards.
I don't see any questions in the Q&A. I do have one person, Sai Krishna. I'm going to actually put you on screen by promoting you to panelist, and you can ask your question live. So others who want to ask questions, if you use raise hand, I will enable you to do that, or you can enter your question via Q&A. Sai, go ahead.
Sorry, I lost your voice a little bit, Sid. But my question to Jason is that in the initial slides, you were saying you were aggregating results between 20 to 50 models, right? So were these models just similar versions of, I mean, it could be the same LDA, but just with different hyperparameters, or what constituted the different 50 to 100 models?
It's effectively the hyperparameters. We've tuned them, and that could be something that we could use as, we could tweak those as well, but these were just basically different seeds for the same models. So the idea being that across different runs, generally topic models have some instability, and in order to be able to smooth out that instability, to be able to actually aggregate the point of the running different runs is to sort of allow the topics which appear consistently across different runs to sort of bubble up and yeah. Got it.
And each topic, when your LDA model spits out a topic, it's just a number, right? It's like topic 0 to topic n. And then you have word probabilities associated with each of these topics. So when you're aggregating topics, how are you doing it? You're trying to look at topic 0 and trying to find what all words are coming within that topic across all the 50 different models with different seeds, and then aggregating it? Or are you trying to look at different topics? The topics themselves could have different numbers, but they could be sharing similar word probabilities and then aggregating that to be a topic.
Yeah, it's the latter. So yeah, you're right that the LDA output would be, sorry, the LDA output would be yeah, a index for a specific topic. And then if you actually look at one of these guys, one of these clusters here, you can see this cluster for eye glaucoma, it constitutes these topics. So it's model 49, that's a index, an internal index, and topic 228. So that's the index for the individual topic. So apparently this is a 400 topic model. And yeah, so then those are aggregated. And so then the cluster, this is the individual topic, and then the cluster has these the top terms here. And I've only showed I think 10 or fewer here, but there's another another vector to indicate the actual the topic or the top terms for the cluster. So those are averaged across all the underlying topics.
Got it. So the aggregation is basically on the positive terms that you're seeing. There could be different topics across different models, but they could be having the same positive terms, and all those are getting together to be aggregated to be one topic.
Yeah, that's right.
Okay. No, thanks.
Okay.
No questions.
All right, Jason, you have a question from Mariam Kazmi in the Q&A. How is the aggregation done, for example, in a sequential manner, parallel manner?
Oh, yeah, that's yeah. So that kind of goes to the optimization portion. It's expensive to aggregate the information, and yeah, can't do it on the fly. So all the data is pre-computed in this pipeline, and so, for example, there is this the pipeline here to compute pairwise distances across for the we get the calculate the distance, the Jensen-Shannon distance between every topic on every model. That's a very expensive portion. So that's parallelized on Spark. And then the actual topic aggregations, that's done when we create these, what I've called the CC data views, or just the data views on this data. So basically, when what we do is create a network graph based on the pairwise distances, create a graph, and then apply a certain threshold. And this is actually something that we try to learn, which is the best threshold. But say for a specific run, we might have, say, a threshold of 0.10 for the Jensen-Shannon distance. We create the graph, create the subgraphs based on that, and then there are some additional heuristics to do to refine that graph. But then we have sort of a stable set of topics per cluster, and for those create a matrix for the term cluster association. If that makes sense.
You have a couple more questions in Q&A, but I got the impression you weren't done. You can take them now, or you can continue to finish your presentation.
Okay. I can take these, and because I'll take these and then go after these three. You're monitoring a certain metric before you decide to stop the iteration for a single model. Model with a particular seed. Is that mean for a specific LDA model?
I'm gonna go on to the next question. I'll enable Sai to speak, since you had a question about his question.
Okay. Actually, I see answered. Yes. No, I used basically when using GenSim, there's a cutoff on when the perplexity doesn't reduce after a certain number of rounds, and the same with the Spark LDA. So I wasn't actively monitoring that, so I was just using the underlying implementation, in this case the Spark LDA. But yeah, if there is no movement in perplexity, then it'll short circuit. Sometimes input the number of topics by hand. How do you choose the right number? Yeah, I'm not sure if I said that, but I think, yeah, I wonder if you can, what point or what is that in reference to?
Sean, I've enabled you to speak, Sean, if you're able to do that. Go ahead. Why don't you, Jason, go on to the final question from Harris Papa Giorgio.
Okay. No, actually, there is not, and that's something that we can, something I've discussed. Yeah, I think because we actually have, sort of an abundance of underlying topics, can sort of infer subtopics within that. But it's something that we haven't done right now. It's been something that's been mentioned as being of interest, to be able to see for a specific cluster and then what subtopics or subclusters there are underneath there. But yeah, it's something we still need to look into.
So that question related to topic hierarchies. Okay, Sean has not clarified his question, so why don't you go on with the presentation?
Okay, all right. And so this is, all right, so you have just to touch on how we were evaluating the clusters. Coherence is a standard way to measure the interpretability of topic models, and so use the coherent CV coherence score is implemented in GenSim, which reflects sort of the co-occurrence of topic terms against the sliding window within documents. And here in this chart show how compare that against individual topic model runs. So the first line there sees for Spark LDA using 400 topics. And this was actually in the header, it's for PubMed Q4 2020. So this is on corporate or input document set of about 400,000 documents. And for those, the 400 topic model, if you look at the columns under full topic model, you can see that the mean coherence was about 0.52, 526, and coherence is on a scale of 0 to 1. But I felt like that wasn't necessarily a fair evaluation or comparison between the model of models, the clusters we've been creating, and the individual model runs, because as I mentioned, we have a sense of ubiquity where the cluster would have to show up in more than 25% of the models in order for it to show up by default, and that's generally the metric that I've been looking at. So in order to make that a fair comparison against the individual LDA runs filtered on the top quartile of coherence scores for those individual LDA runs and average those. And so for those, for the top 100 out of 400 for those, the average was 0.667 as opposed and compared to the model of models, which had an average coherence of 0.709. And yeah, just to kind of give a sense of the number of topics, it was 106 topics versus 100 in this case. Those are the ones highlighted in red. There were additional model of model runs with different coherence scores and different topic numbers. And I just sort of illustrate those to show that there's an inverse relationship between the number of topics. As the number of topics decrease, the coherence score increases. Perhaps the topics are safer, more, but then you have fewer topics and clusters in that case, and maybe you're missing out on some information. So was trying to strike the right balance there, and we do that by just ranking the model of model clusters. Okay. All right, so then scaling with PySpark. All right, so yeah, as I mentioned, a lot of this computation is expensive, cannot do this on the fly. And in order to be able to render it efficiently, have to create cache views of the data. And parallelization is key to scaling. And the actual generation of the LDA models, that is relatively not that expensive. They're parallelized naturally through the Spark framework. So as long as one has enough hardware, which using EMR spot instances, I think they're relatively cheap enough to spin up. You can get good throughput, say even for 50 models, and I'll give some numbers in a later slide. But some of the other things that are not parallelized naturally through Spark, that was where a lot of the bottlenecks occurred. For example, computing the pairwise distances also pre-computing a lot of the views and the matrices. So that's where a lot of the additional optimization work had to occur. I'll maybe talk a little bit about those a little later, but then I'll just go into the Spark LDA, because I think that's the thing that's probably most generalizable for folks on the call. In the past, I would use GenSim, which is a great tool, but I found it hard to be able to scale that. I tried running GenSim using LDA multi-core on a Spark cluster, and didn't get as much throughput as I was hoping. But then just using Spark LDA, because it just naturally parallelizes on a Spark cluster, on a cluster, the throughput was pretty good. For example, you can just see in the table below, it's I threw this together so it's a little bit noisy, but I think what you can try to take out of this is on the left-hand side, it's Q4 2020 for PubMed, so it's about 400,000 documents and 100 iterations, and you can do that across 400 topics. For one model, it'll take about an hour to do that. So if you want, for my purposes, I need to do 12 models, and that took about 12 hours. But also for a smaller corpus, for say 30,000 documents, it's on per model, it's less than 10 minutes each. So if you have a 400 topic model you want to generate for one of these 30,000 document smaller mid-size document sets, it'll take about 8 to 10 minutes to do that. So that's just to say that using Spark, the generation of the models becomes relatively cheap. And this was done on 2 R5 8X large boxes. And if you use a spot instance, it's about 36 cents an hour. So the cost is about, yes, $34 if you need to run it for a couple of days. And I just threw this Spark LDA example here as well, just because I've seen many examples for GenSim, but not as many for Spark. So yeah, just I think one could throw this together as well, but if you want a reference for this, I can post the slides for Seth if you want to take a look. And just some of the other things around scaling. Yeah, I mean, some basic EMR and Spark stuff. I mean, use spot instances because they're so much cheaper than the on-demand instances, and also having a core node that's but having a core node that's not a spot instance. So if you have a run longing job and you don't want Amazon to kill the driver out from under you, you need one that's you're paying the on-demand price for it, but you can have a smaller box for that. Important thing is also to write the checkpoint state to S3 in case the spot instances are dropped. There's nothing more frustrating than having a job running for 2 days and then Amazon killing it when it's most of the way through and having to start over. So I found really writing the checkpoint state to some persistent store, in this case S3, really helped with the throughput. And because a lot of these jobs have a lot of different memory requirements, being able to tune the memory or specify the memory parameters for each of the different steps, I think that's important. So I created a small framework for myself to be able to say for each particular step in that pipeline, what are the memory parameters? In certain cases, you really need, say, 60 gigs, 100 gigs for a job. Other cases, that's overkill. And there's really a trade-off between the memory you allocate and the amount of parallelization you can have. Because memory is sort of the resource that those jobs need. So say you have 200 gigs on a machine and you want to parallelize. If you allocate 50 gigs for every executor node, you only have 4 processes. But if you can get that down to say 10 gigs per executor, then you have, you can get 20 processes going there. And just sort of along those lines, if you can do things in the driver, you can trade off memory for parallelization of the executors. So if you have things that you need to load into memory, then you can dispatch that to the executors. I would say do that, maybe allocate 40, 50 gigs for the driver, and then make the executors a lot more lightweight. I mean, these are all specific things for EMR Spark, but I found that once I've kind of understood some of these things, that the pipelines became much more reliable and faster. And just, yeah, the final thing is that watching out for library dependencies which do multi-processing. And this is a general thing, but things like gensim, joblib, or even PyLDA-viz, they'll spawn subprocesses, and that can cause memory issues, especially if your parent process has loaded a big model into memory. By default, multiprocessing is set defaults to fork, and it'll replicate the entire memory space for the parent process into the child process. So I was getting executors that were blowing up. Say if I have like a 20 gig model in the parent process, create 10 child processes, all of a sudden I need 200 gigs extra, and Spark would fall over. So setting multiprocessing sets, and you can set start method to spawn. It'll take longer to create the child processes, but yeah, you'll be able to pay that back, get that paid back in being able to parallelize more aggressively. Yeah, and just next steps, I think just looking for additional use cases. I think there's we have something interesting. The part of that is the model of models, aggregating the topic models. Also, the work we've been doing to sort of streamline the Spark execution. I feel like there is, yeah, there is other use cases we could use that for. And there's some other technical things like pushing the upper limit for the corpus size, making the models, generation models more lightweight, and other ways to evaluate the cluster. Those are some things I've been thinking about. But I think, yeah, additional use cases and yeah, ways to take this, different places to take the project. Be interested in finding out if anyone has any thoughts there. And yeah, that's it. And if there's any additional questions, happy to take them now.
So folks can enter questions via Q&A or use raise hand, and hopefully we'll avoid any spammers. If you want to be voice enabled, you do have a comment from Dr. Steve Kramer in the Q&A saying that there's a COVID-focused dashboard created by Primer, which is at covid19primer.com/topics. And then someone has asked you, Jason, could you post a link for the scaling slide? Interested to see the article you listed. Okay. So Jason, I have one, thank you for the presentation. It's really interesting always to hear people who have actually done, let's call it exploratory work, and to give practical guidance about the issues like the need for checkpointing, concern for memory and computational time and expense. It's very useful to hear that kind of thing. You had communicated to me a few months ago an interest in commercializing this work that you've talked about. Are you heading anywhere with that?
Yeah, I haven't been able to take that further, but I'd be interested in, yeah, if there's anybody who has thoughts along those lines, yeah, having those conversations. I'm coming at it from an engineering perspective, and I feel like there's an interesting engineering angle or a tool here, but yeah, be interesting to hear what kind of a market there is for that.
All right, well, if anyone wants to approach Jason with further questions or with thoughts about commercialization potential and markets and so on, please do get in touch with him. So I think that wraps us up for today. So thank you very much, Jason, for your presentation. So once again, to all attendees, we don't have another session scheduled yet, but if you would like to give a talk at a future session, potentially online or potentially in person for my meetups in New York or in Washington, D.C., you should send me a note. And the video for this meetup today should be posted later today. I'm in the US, so give me a few hours, to the NLPXING YouTube channel. And finally, once again, thank you to our two sponsors, John Snow Labs and Kensho. Please do, again, get in touch if you have any questions that you think I might help you with, or if you're interested in potentially giving a talk at a future meetup. See you all at a future program. Bye.